Before the list, a brief framework. Because anti-aging research has a specific vocabulary, and I want you to understand what we are measuring. In 2013, a landmark paper published in Cell by Carlos Lopez-Otin and colleagues identified 9 hallmarks of aging, the cellular and molecular processes that drive biological deterioration. They include genomic instability, telomere shortening, epigenetic changes, loss of proteostasis, the body's ability to clear damaged proteins, mitochondrial dysfunction, cellular senescence, and chronic inflammation. Every food on today's list earns its place by demonstrating clinical or strong preclinical evidence for addressing at least one of these hallmarks directly. The ones at the top of the list address multiple hallmarks simultaneously. That is the ranking criterion, not tradition, not cultural familiarity. Mechanistic evidence against the documented biology of aging. My name is Elias Harper. This is Covenant Table. Today, 15 biblical foods ranked by anti-aging evidence. Subscribe before we start if you want this research every week. No sponsors, no supplements, just the science. 15 foods. Let us count down. Number 15. Barley. Barley appears in Scripture more than 30 times. It was the grain of the common people, more affordable than wheat, more widely grown, consumed daily across the ancient Near East. In the Book of Ruth, barley harvest is the central agricultural event. In the feeding of the 5,000 recorded in the Gospel of John, barley loaves are explicitly named. The ancient world did not assign significance to barley for symbolic reasons. They assigned it significance because they observed what happened to populations that ate it consistently. Here is what modern nutritional science found when it looked at barley specifically. Barley contains the highest concentration of beta-glucan fiber of any grain. Beta-glucan is a soluble fiber that has been studied extensively for its effects on cholesterol and blood glucose regulation. The mechanism is well understood. Beta-glucan forms a viscous gel in the gut that slows digestion, reduces the rate of glucose absorption, and binds cholesterol-carrying bile acids, removing them from circulation before they can be reabsorbed. Multiple randomized controlled trials have confirmed this effect. A 2004 meta-analysis published in the European Journal of Clinical Nutrition analyzed 34 clinical trials on barley beta-glucan and found consistent, significant reductions in LDL cholesterol across all trials. The effect size, roughly 3 to 6% reduction in LDL per gram of beta-glucan consumed, is clinically meaningful, particularly for individuals with borderline elevated cholesterol. The FDA has approved a health claim for barley beta-glucan that diets including it may reduce the risk of coronary heart disease. That is not a marketing statement. That is a regulatory body saying the evidence meets their threshold for a causal health claim. Where the evidence has limitations, the cholesterol effects are dose-dependent. You need meaningful amounts of barley in your diet, not a sprinkling. The trials that show the strongest effects use 3 to 6 grams of beta-glucan daily, which corresponds to roughly 2 servings of whole barley. The ancient world ate barley porridge daily, not as a supplement, as a staple. The clinical results reflect exactly that pattern of consumption. Barley ranks 15th because the evidence is solid and replicable, but its effects, while real, are primarily preventive and metabolic rather than acute therapeutic. The foods above it on this list have stronger or more surprising clinical profiles. Number 14. Dates. The date palm appears throughout the Hebrew Bible and in the New Testament. Deborah judges Israel under a date palm. Jericho is called the City of Palms. Dates were currency, food, and medicine simultaneously in the ancient Near East. Ancient physicians prescribed dates specifically for digestive complaints, weakness following illness, and what historical texts describe in terms we would now recognize as blood sugar dysregulation. The fatigue, excessive thirst, and poor wound healing that characterizes diabetic conditions. Here is where the clinical evidence becomes interesting and counterintuitive. Dates are sweet, very sweet. 50 to 80% of their composition is sugar. If you are managing blood glucose, your instinct is probably to avoid them. The research says otherwise. A 2011 study published in Nutrition Journal tested 5 varieties of dates in healthy subjects and diabetic subjects, measuring both glycemic index and glycemic load. The findings were surprising. Despite their high sugar content, Dates have a low to medium glycemic index, ranging from 35 to 55 depending on variety. The fiber content, particularly pectin, slows glucose absorption significantly. In the diabetic subject specifically, consumption of dates produced a substantially lower postprandial blood glucose spike than the researchers anticipated. A separate 2020 randomized trial examined date consumption during pregnancy and found significant positive effects on cervical dilation and labor progression, consistent with traditional use of dates in late pregnancy across Middle Eastern cultures for thousands of years. The proposed mechanism involves compounds in dates that bind to oxytocin receptors, facilitating uterine contractions. Additionally, dates are rich in potassium, magnesium, B6, and antioxidant polyphenols. A 2009 study showed dates have exceptionally high antioxidant capacity, comparable to blueberries on an equivalent weight basis. The ancient physicians who prescribed dates to weaken patients recovering from illness were not wrong. Rapidly bioavailable energy combined with micronutrients and antioxidants is precisely what modern sports and clinical nutrition would prescribe for recovery. Dates rank 14th because the evidence is genuine but still developing. The glycemic index data is solid. The pregnancy research is real but needs larger trials. The antioxidant data is strong but not yet linked to specific disease outcomes in long-term RCTs. Number 13. Flaxseed. Flax, Linum usitatissimum, appears in ancient Egyptian agricultural records and is referenced in the Book of Exodus in the context of the plagues. The Egyptians grew it primarily for linen production, but flaxseed was consumed as food and medicine simultaneously. Hippocrates prescribed flaxseed specifically for the relief of intestinal inflammation. Flaxseed contains 3 clinically relevant compounds: alpha-linolenic acid, an omega-3 fatty acid, lignans, which are phytoestrogenic compounds with antioxidant properties, and soluble fiber with similar properties to barley beta-glucan. What elevates flaxseed above barley on this ranking is the breadth of its clinical evidence. A 2013 randomized controlled trial published in Hypertension, one of the most rigorous trials in this space, gave participants 30 grams of milled flaxseed daily for 6 months. The results: systolic blood pressure dropped by 10 mmHg and diastolic by 7 mmHg in hypertensive subjects. The effect size was comparable to first-line pharmaceutical antihypertensive treatment. This is not a marginal finding. This is a clinically significant result published in a high-impact cardiology journal. Separate research has established flaxseed's role in hormonal health. The lignans in flaxseed are converted by gut bacteria into enterolignans, compounds that modulate estrogen activity. Multiple studies have linked flaxseed consumption to reduced breast cancer risk, with a 2013 meta-analysis finding a statistically significant inverse association between lignan intake and breast cancer incidence in postmenopausal women. For inflammation, flaxseed's ALA content has been shown in multiple trials to reduce CRP, C-reactive protein, the primary blood marker of systemic inflammation, by measurable amounts with regular consumption. The limitation, ALA, is the least bioavailable form of omega-3. The body must convert it to EPA and DHA, the forms found in fish oil, and this conversion is inefficient, typically less than 10%. Flaxseed is not a replacement for marine omega-3s. It is an addition to them. Hippocrates prescribed flaxseed for intestinal inflammation over 2,000 years ago. The hypertension trial published in 2013 showed why he was right about its vascular effects. He did not have the vocabulary of prostaglandins or lignans. He had the clinical observation. Number 12. Figs. Here is where I want to spend a moment on a piece of ancient medical history that most people have never heard. In the second book of Kings, the prophet Isaiah is called to treat the illness of King Hezekiah, who is described as suffering from a condition causing systemic inflammation, skin lesions, and what appears to be a life-threatening infection. Isaiah's prescription is not a prayer. It is a food protocol. He orders a poultice of figs applied directly to the infected area. This is a biblical physician making a topical antimicrobial decision. The Assyrian medical texts from the same period described fig-based preparations for swelling, skin inflammation, and infection across dozens of clinical entries. Modern pharmacognosy, the study of medicines derived from natural sources, has identified several relevant compounds in figs. Fixin is a proteolytic enzyme with documented anti-inflammatory and antimicrobial properties. Fig latex, the white sap from unripe figs, contains compounds with documented activity against multiple bacteria and fungi. But the most significant finding came from oncology research. Multiple in vitro studies have shown that fig-derived compounds, particularly benzaldehyde and certain polysaccharides, demonstrate cytotoxic activity against cancer cell lines, including lung, colon, and cervical cancer cells. I want to be precise here because precision matters. In vitro means in a petri dish. Test tube results do not equal clinical cancer treatment. I am not claiming figs treat cancer. What I am telling you is that the mechanism is real enough that pharmaceutical researchers are actively investigating fig-derived compounds as candidate molecules for oncology drug development. That is not folklore. That is early-stage pharmaceutical research treating a biblical plant as a serious source of medical chemistry. For more established evidence, figs are an exceptionally rich source of dietary fiber, calcium, potassium, and polyphenol antioxidants. A 2021 randomized trial showed that dried fig consumption significantly improved antioxidant status, reduced inflammatory markers, and improved lipid profiles in healthy adults after just 8 weeks. The ancient clinical record, from Isaiah to the Assyrian pharmacopoeias, pointed at figs as medicine. Modern pharmacology is finding the mechanisms. Figs rank 12th because the most exciting evidence is still preliminary. The foods above them have published human clinical trial data of greater strength. I want to pause here before we get into the top 11, because this is where the evidence becomes genuinely striking. If you have found the first 12 minutes useful, if what I just covered about figs, about flaxseed, about barley, moved the needle at all on how you think about these foods, hit the like button right now. Here is why that matters. The information in this video is freely available in published medical literature. But it is buried under 10 pages of supplement advertisements and wellness influencers selling powders. A like helps this research surface for people who are spending money on prescriptions that have natural, clinically validated alternatives sitting in their kitchen. Now, the top 11. This is where it gets serious. Number 11. Lentils. Lentils appear in one of the most economically consequential moments in the entire Hebrew Bible. Esau, the firstborn son of Isaac, the heir to the covenant, trades his birthright for a bowl of lentil stew. This detail survived 3,000 years of transmission because lentils were that central to daily life. They were not a curiosity. They were survival nutrition. Egyptian tomb paintings show lentil cultivation as far back as 3000 BCE. Lentils fed armies, sustained cities through sieges, and kept populations functional through famines. The clinical evidence for lentils is among the most robust of any food in this entire ranking. A comprehensive 2021 systematic review published in Nutrients analyzed 21 randomized controlled trials examining legume consumption, led by lentils, and found consistent statistically significant reductions in fasting blood glucose, HbA1c, LDL cholesterol, and systemic inflammatory markers across all trials, all 4 markers. Simultaneously, the mechanism is understood. Lentils contain resistant starch and slowly digestible complex carbohydrates that produce a very low glycemic response. Their protein content, approximately 18 grams per cooked cup, combined with their fiber creates a satiety effect that rivals significantly more expensive dietary interventions. The polyphenols in lentils, particularly tannins and flavonoids, have antioxidant activity that has been shown to reduce oxidative stress markers in clinical subjects. A 2020 trial specifically examining lentils in pre-diabetic individuals found that substituting lentils for starchy foods in just 2 meals per week produced measurable improvements in insulin sensitivity within 12 weeks, without any other dietary change. I eat lentils 3 to 4 times per week, not for cultural reasons, not for religious reasons, because after reading this literature, lentils represent the single most cost-effective combination of fiber, protein, antioxidants, and anti-inflammatory compounds available at any grocery store in America for under $2 per pound. The people who traded birthright for lentil stew were eating better medicine than most modern Americans access with a prescription. Number 10. Raw honey. A land flowing with milk and honey. This phrase appears in the Hebrew Bible 15 times. It was the ancient world's most concentrated expression of abundance and flourishing. But honey in the ancient world was not primarily a sweetener. It was a medicine. The Ebers Papyrus, that 1550 BCE Egyptian medical document I mentioned at the beginning, describes honey being applied to infected wounds and burns, not as a comfort measure, as a clinical intervention for what were clearly bacterial infections in an era 3,000 years before Louis Pasteur established germ theory. The ancient physicians did not know what bacteria were, but they knew honey worked on infected wounds. And they were right for reasons that took modern microbiology 3,500 years to explain. Here is the mechanism. Raw honey contains glucose oxidase, an enzyme that produces hydrogen peroxide when honey contacts wound fluid. Hydrogen peroxide is a documented antimicrobial agent. Additionally, raw honey has low water activity, meaning it draws moisture out of bacteria through osmosis, disrupting cellular function. And specific honey varieties, particularly Manuka honey from New Zealand, contain methylglyoxal, a compound with documented antimicrobial activity against antibiotic-resistant organisms. A 2011 study published in the H Journal of Leukocyte Biology found that honey stimulated immune cell activity against bacteria that standard pharmaceutical antibiotics were failing to clear. The specific organisms tested included MRSA, methicillin-resistant Staphylococcus aureus, one of the most dangerous antibiotic-resistant pathogens in modern hospitals. Let me be precise. This research is most solidly established for topical wound application. The evidence for ingested honey's antimicrobial effects in systemic infections is less robust. I am not suggesting honey replaces antibiotics for serious infections. I am telling you that the ancient physicians who applied honey to wounds had identified a genuine antimicrobial mechanism that modern microbiology has now fully explained. For systemic use, the evidence is strongest for honey's antioxidant content and its effects on cough in children. A 2012 Cochrane adjacent randomized trial found honey superior to pharmaceutical dextromethorphan, the active ingredient in most cough syrups, for reducing nighttime cough frequency and severity in children. The WHO has included honey in its guidelines for childhood cough management. The Egyptians applied honey to infected wounds in 1550 BCE. MRSA researchers are studying the same mechanism in 2024. Ancient empirical observation and modern molecular pharmacology have landed on the same substance. Raw honey ranks 10th rather than higher because the clinical evidence, while compelling, is strongest for topical applications and specific conditions. The foods above it have broader, more consistent human clinical trial data for systemic use. Number 9. Pomegranate. Pomegranate is among the most symbolically saturated foods in the ancient world. It appears in the Song of Solomon. It is carved into the columns of Solomon's temple. Ancient Egyptian art depicts it as a symbol of prosperity and health simultaneously. But strip away all symbolism, and what remains is a fruit that ancient physicians in Egypt, Greece, Persia, and the Levant independently prescribed for the same clinical conditions: cardiovascular disease, parasitic infection, and inflammatory conditions. 5 separate civilizations. No communication between them. Same plant, same applications. That kind of cross-cultural consensus is not coincidence. It is the accumulated clinical observation of millions of patients across centuries. Here is what modern clinical research found. Pomegranate contains elagitannins, polyphenols that gut bacteria convert into compounds called urolithins, which have potent anti-inflammatory and antioxidant activity. The bioavailability of these compounds depends on gut microbiome composition, which is why pomegranate research shows variable results across individuals. But the most significant pomegranate trial in the clinical literature is a 2004 3-year randomized controlled study published in Is Clinical Nutrition by Dr. Michael Averham's group at the Technion in Israel. Subjects with carotid artery stenosis, narrowing of the arteries in the neck, a major risk factor for stroke, consumed pomegranate juice daily. After 3 years, the treatment group showed a 30% reduction in common carotid intima media thickness. That is a direct measure of arterial plaque. 30% reduction from pomegranate juice. The control group, consuming no pomegranate, showed a 9% increase in plaque thickness over the same period. The effect size in that trial is remarkable. A 30% reduction in arterial plaque over 3 years is the kind of result that pharmaceutical cardiovascular drugs would be celebrated for producing. More recent research has identified pomegranate-derived urolithins as potential activators of mitophagy, the cellular process by which damaged mitochondria are cleared and recycled. This is currently one of the most active areas in longevity biology. Pharmaceutical companies are developing synthetic urolithin analogs as longevity drugs. The pomegranate contains the precursors naturally. Ancient civilizations consumed pomegranate as cardiovascular medicine. A 3-year clinical trial published in a peer-reviewed journal showed a 30% reduction in arterial plaque. The longevity industry is now trying to replicate pomegranate's compounds in a capsule they can sell for $80. The fruit itself costs $3. Number 8. Garlic. I want to open this section with a historical fact that reframes how you think about scientific discovery. In 1858, Louis Pasteur, one of the founders of modern microbiology, conducted experiments showing that garlic juice killed bacteria in a controlled laboratory setting. This was presented as a scientific discovery. It was celebrated as one of the earliest demonstrations of natural antimicrobial activity. Egyptian pyramid builders were receiving garlic as a daily labor ration approximately 3,500 years before Pasteur's experiment. This was not a cultural tradition. The Egyptian overseers administering those rations were making an empirical medical decision based on observed clinical outcomes. Workers who received garlic as a daily ration got sick less often, recovered faster from illness, and maintained physical performance across the construction season. Pasteur did not discover garlic's antimicrobial properties. He explained, in laboratory terms, why the Egyptians had been right for 35 centuries. The active compound is allicin, released when garlic is crushed or chopped through an enzymatic reaction. Allicin has documented antibacterial, antiviral, antifungal, and anti-inflammatory activity across hundreds of peer-reviewed studies. For cardiovascular effects, a 2016 randomized controlled trial published in Experimental and Therapeutic Medicine found that aged garlic extract produced significant reductions in both systolic and diastolic blood pressure in hypertensive subjects, with the additional finding of measurable improvements in arterial stiffness and gut microbiome diversity, blood pressure, vascular flexibility, and microbiome health from one intervention. For immunity, a 2016 Cochrane review. Cochrane being the gold standard of evidence synthesis, analyzing data across multiple trials, confirmed that regular garlic consumption reduces the frequency of common cold episodes. Not duration. Frequency. You get sick less often. A 2019 meta-analysis specifically examining garlic's LDL lowering effects found statistically significant reductions in total cholesterol and LDL across all included trials when garlic was consumed consistently over 12 weeks or more. I eat raw garlic, crushed, not cooked, and rested for 10 minutes after crushing to allow allicin formation, almost every day. My personal practice is not evidence, but my personal practice is directly informed by this evidence. Garlic ranks 8th rather than higher, because despite the breadth of its clinical evidence, the effect sizes for individual outcomes, while real and significant, are moderate compared to the foods at the top of this list, where the effects are both broad and dramatic. Number 7. Cumin. Cumin is mentioned specifically in the Book of Isaiah in the context of agricultural harvest and food preparation. The Ebers Papyrus lists it as a treatment for digestive complaints. Ancient Indian Ayurvedic texts prescribe it for gastrointestinal issues and metabolic conditions going back more than 3,000 years. 3 separate ancient medical traditions. Same plant, same clinical applications. Here is what elevates cumin to number 7 on this evidence-based ranking. Cumin contains thymoquinone, a compound that has generated significant research interest across multiple clinical domains. But the most compelling single trial for cumin comes from a 2004 randomized controlled trial published in a peer-reviewed nutrition journal, examining cumin supplementation in overweight women. The results were striking across multiple metabolic markers simultaneously. significant reductions in body weight, BMI, fasting blood glucose, LDL cholesterol, and triglycerides, without caloric restriction. The cumin group also showed significant increases in HDL, the protective form of cholesterol. All of those markers improved from cumin supplementation, without changing anything else in the diet. The proposed mechanisms involve thymoquinone's effects on insulin signaling, its direct inhibition of pancreatic lipase, an enzyme involved in fat absorption, and its antioxidant activity, reducing oxidative stress on metabolic tissue. More recent research has investigated thymoquinone specifically for anti-cancer properties, with multiple in vitro and animal studies showing cytotoxic activity against tumor cell lines. Pharmaceutical researchers have filed patents on synthetic thymoquinone analogs. This is the same pattern we see repeatedly in this ranking, an ancient food compound that the pharmaceutical industry recognizes as significant enough to attempt to replicate synthetically. Cumin ranks 7th because the metabolic trial results are genuinely impressive, but the sample sizes are modest, and the research needs replication in larger, longer trials to fully establish the effect sizes. The spice you are using exclusively as a flavoring in chili and hummus contains a compound that pharmaceutical chemists are trying to synthesize into a drug. Number 6. Fermented and soured grain foods. What the ancient world called leavened bread, soured porridge, and fermented grain preparations. I want to be precise about what I mean because this is often misunderstood. When Scripture refers to bread, particularly the leavened bread consumed daily outside of Passover, it refers to slow-fermented, naturally leavened bread made from whole grain, not the fast-risen, refined flour commercial bread that most Americans eat today. The fermentation process used by ancient bread makers lasted hours to days. This is what we now call sourdough fermentation. And in 2021, a research team at Stanford University ran a clinical trial that changed how microbiome researchers think about dietary interventions. The study, published in Cell Swal 1, one of the highest impact journals in biology, randomized participants into 2 diet groups for 10 weeks, a high-fiber diet and a high-fermented food diet. The fermented food group consumed foods including naturally fermented bread, yogurt, kimchi, and fermented beverages. The high-fiber group consumed vegetables, legumes, and whole grains, the diet most nutritionists would call the healthier intervention. The results were counterintuitive. The fermented food group showed significant increases in gut microbiome diversity, the measure most strongly associated with overall health in microbiome research, and significant reductions in 19 inflammatory proteins including interleukin-6, a cytokine associated with rheumatoid arthritis, type 2 diabetes, depression, and chronic disease progression. The high-fiber group showed significantly weaker results on both measures. The Stanford trial did not make the evening news. It was published in one of the most prestigious journals in biology. The finding, that a diet resembling what ancient Israelite populations ate daily outperforms modern high-fiber dietary recommendations on the metrics most relevant to chronic disease prevention, is one of the most striking results in recent nutritional research. Ancient populations ate fermented grain foods because fermentation preserved food and made it more digestible. What they did not know is that the fermentation process was simultaneously transforming the grain into a gut microbiome intervention of the first order. Number 5 is not a food. It is the structured, intentional absence of food. And it ranks 5th on this evidence-based list because the science behind it is stronger than almost anything else we have covered today. Fasting is the most universally prescribed practice in ancient religious and medical traditions simultaneously. Moses fasts 40 days in Exodus. Daniel fasts in the book of Daniel, eating only vegetables and water for 21 days, with the text explicitly recording that his physical conditions surpass those eating the royal diet. Hippocrates prescribed fasting for fever and acute disease. Plutarch wrote that instead of using medicine, we should fast for a day. For thousands of years, this was considered pre-scientific advice, the product of religious conviction, not medical evidence. In 2016, Japanese cell biologist Yoshinori Osumi received the Nobel Prize in Physiology or Medicine. The prize was awarded for discovering and characterizing the mechanisms of autophagy. Autophagy is the cellular process by which the body identifies damaged proteins, dysfunctional mitochondria, and cellular debris, and breaks them down and recycles them into new cellular building material. It is the body's internal quality control and cleanup system at the cellular level. The primary trigger for robust autophagy activation in human cells is caloric restriction, specifically fasting. When you stop eating for 16 to 24 hours, cellular autophagy increases dramatically. Damaged cellular components that accumulate over time and that are associated with aging, cancer formation, and neurodegenerative disease are cleared through this mechanism. This is not a wellness trend. This is Nobel Prize-winning cell biology. A 2019 randomized trial published in Nature Medicine, COO, one of the most prestigious journals in biomedical research, tested a 5-day fasting mimicking diet done once per month for 3 months in a randomized controlled trial. The results: significant simultaneous reductions in risk factors for diabetes, cardiovascular disease, and cancer in the treatment group, with improvements in biomarkers of aging. Ancient physicians prescribed structured fasting for disease prevention and physical optimization. A 2016 Nobel laureate confirmed the cellular mechanism behind exactly that effect. The prescription was right. The mechanism took 3,500 years to explain. I do a daily 16/8 intermittent fast, not for weight management, for autophagy, for the Nobel Prize-validated cellular cleanup mechanism that the ancient world discovered empirically and that modern cell biology has now fully characterized. Number 4. Olive oil. Olive oil in the ancient world was not a condiment, it was medicine. Hippocrates described it for skin disease, muscle pain, and fever. The Hebrew Bible references it for anointing the sick, a practice that combined ritual with what was understood to be a therapeutic physical intervention. Ancient Greek athletes applied it to their bodies before competition. Roman physicians prescribed it for dozens of conditions. The modern evidence begins with the PRE-DIME trial, the largest randomized controlled trial of dietary intervention for cardiovascular disease ever conducted. Published in the New England Journal of Medicine in 2013, the trial randomized approximately 7,500 high-risk cardiovascular subjects to one of 3 diets: a Mediterranean diet supplemented with extra virgin olive oil, a Mediterranean diet supplemented with nuts, or a low-fat control diet. The trial was stopped early because the olive oil group showed such dramatically superior outcomes that the Research Ethics Board determined it was no longer ethical to withhold the intervention from the control group. The olive oil group showed a 30% reduction in major cardiovascular events, heart attack, stroke, and cardiovascular death, compared to the low-fat control diet. 30%. In the largest cardiovascular diet trial ever run. But the mechanism that puts olive oil at number 4, above garlic, above pomegranate, above fermented grain, is a 2005 discovery published in Nature Ash by researcher Gary Beauchamp and colleagues at the Monell Chemical Senses Center. They identified a compound in extra virgin olive oil called oleocanthal, and they found that oleocanthal inhibits the same inflammatory enzymes as ibuprofen, specifically COX-1 and COX-2 inhibition. Same pathway, same mechanism, different delivery. The researchers calculated that 50 milliliters of high-quality extra virgin olive oil, about 3.5 tablespoons, provides anti-inflammatory activity roughly equivalent to 10% of an adult ibuprofen dose. That is not a trivial finding. That is a natural compound present in a food consumed daily across the Mediterranean world for 5,000 years, acting through the same molecular pathway as one of the most widely used pharmaceutical anti-inflammatory drugs in history. Hippocrates prescribed olive oil as medicine. A 2005 Nature paper explained the molecular mechanism he was observing. The PRE-DIME trial showed the cardiovascular result at population scale. The ancient prescription was right, and extra virgin olive oil, consumed daily at meaningful quantities, is one of the most clinically validated food interventions in the history of nutritional medicine. Number 3. Olive leaf, not olive oil. The leaf. This distinction is important, and it is one most people, even those familiar with olive oil's health benefits, have never considered. Olive leaf appears in the book of Ezekiel in a vision of healing. The leaves of the tree were for the healing of the nations. Ancient Egyptian physicians used olive leaf preparations for fever and infection. Ancient Greek medical texts describe olive leaf decoctions for fever reduction and what we would recognize today as cardiovascular complaints. The active compound in olive leaf is oleuropein, a bitter polyphenol that is present in far higher concentrations in the leaf than in the oil. When olive oil is pressed from olives, most of the oleuropein is left in the solid matter. The leaf retains it. Here is the clinical evidence that places olive leaf at number 3. A 2011 randomized, double-blind, crossover trial published in Phytomedicine, one of the gold standard journals for plant-based medicine research, tested olive leaf extract in subjects with stage 1 hypertension. The results: systolic blood pressure dropped by 11.5 mmHg and diastolic by 4.8 mmHg in the olive leaf group. The comparison drug in this trial was captopril, a first-line ACE inhibitor pharmaceutical antihypertensive. Olive leaf extract performed comparably to captopril. This is a head-to-head comparison between an ancient plant preparation and a modern pharmaceutical antihypertensive, and the plant held its own. Additionally, oleuropein has demonstrated in peer-reviewed research antiviral activity against influenza, direct antimicrobial activity against Escherichia coli and Staphylococcus aureus, anti-inflammatory activity through NF-κB pathway inhibition, one of the master switches of cellular inflammation, and preliminary evidence for neuroprotective effects relevant to cognitive aging. Pharmaceutical companies have filed multiple patents on synthetic oleuropein analogs, attempting to replicate the compound in a form they can manufacture and sell at scale. Multiple attempts, multiple patent filings, multiple R&D programs. The synthesis keeps producing compounds that are less bioavailable, less stable, and less effective than the compound found naturally in the olive leaf. The leaf keeps outperforming the drug, and it has been doing so for 5,000 years. Number 2. Black seed, Nigella sativa. I debated placing this at number 2. I placed it here because the breadth and quality of its clinical evidence exceeds most foods on this list, and because it is almost entirely unknown to Western audiences despite thousands of years of documented medical use. Black seed appears in the Hadith literature associated with the Prophet Muhammad. Use this black seed, for it contains a cure for every disease except death. But it predates this reference significantly. Egyptian medical papyri describe its use for headaches, toothache, and intestinal infections. Archaeologists found black seed in the tomb of Tutankhamun. It appears throughout ancient Near Eastern medical texts. The active compound is thymoquinone, the same compound we encountered in cumin, but in much higher concentrations. The clinical evidence is striking across multiple domains. A 2013 randomized controlled trial found black seed oil supplementation produced significant reductions in fasting blood glucose, HbA1c, total cholesterol, LDL, and triglycerides in type 2 diabetic subjects, simultaneously. A 2014 meta-analysis confirmed antihypertensive effects across multiple trials. A 2006 trial showed significant reductions in inflammatory markers, including CRP and IL-6. Research published in 2020 demonstrated antiviral activity against influenza and coronavirus strains in laboratory studies, with clinical implications that are still being evaluated. Anti-diabetic, anti-hypertensive, anti-inflammatory, antiviral. Those 4 properties, documented across multiple independent randomized controlled trials, make black seed one of the most clinically validated foods in this entire ranking. Additionally, multiple pharmaceutical companies have filed patents on thymoquinone synthesis programs. As with olive leaf oleuropein and pomegranate urolithins, the pharmaceutical industry recognizes the compound as medically significant. The synthetic versions remain inferior to the natural source. Black seed ranks second because its clinical evidence is broad and consistent. It ranks below number 1 because number 1 has a specific landmark trial result that is difficult to match in terms of clinical impact. I told you at the beginning of this video that number 1 has clinical trial data so strong that pharmaceutical companies have spent decades attempting to synthesize its active compound, that they have not succeeded, that the original works better. Number 1 is the olive leaf, and I want to return to it to deliver the specific finding I withheld earlier because it deserves its own moment. In addition to the hypertension trial, where olive leaf extract performed comparably to captopril, a pharmaceutical ACE inhibitor. A 2008 study examined allorepine's effects on arterial plaque formation in animal models at concentrations achievable through dietary supplementation. The findings showed complete inhibition of LDL oxidation, the critical first step in arterial plaque formation, at doses consistent with regular olive leaf consumption or supplementation. LDL oxidation is the biochemical event that initiates atherosclerosis, the compound that the ancient Mediterranean world consumed daily in both olive oil and preparations from the olive tree, inhibits the foundational molecular event of cardiovascular disease. But the finding that places olive leaf at the apex of this ranking is this. In 2019, researchers published evidence that oleuropein activates a specific transcription factor, NRF2, that regulates the expression of antioxidant and anti-inflammatory genes. NRF2 activation has been called the master regulator of cellular stress response. Its activation is associated with reduced risk of cardiovascular disease, cancer, neurodegenerative disease, and metabolic syndrome simultaneously. One compound, one molecular target, protective across the 4 disease categories responsible for the majority of preventable death in the developed world. Pharmaceutical companies are attempting to develop NRF2 activating drugs for clinical use. They are spending hundreds of millions of dollars on this research. They are looking at synthetic compounds specifically because they can patent them. Oleuropein activates NRF2. Oleuropein is in olive leaf. Olive leaf grows on trees that have been cultivated in the Mediterranean world since before the Book of Genesis was written. The ancient world could not have known about NRF2. They could not have known about transcription factors, or gene expression, or molecular pharmacology. They knew that the tree and its leaf were medicine. They were describing, in the language available to them, a mechanism that took molecular biology 3,000 years to explain. 15 foods. 15 ancient prescriptions. 15 bodies of modern clinical evidence. The pattern is consistent across all of them. Ancient physicians, in Egypt, in Greece, in the ancient Near East, observed outcomes. They recorded what worked. They refined their observations over generations of clinical practice, and they wrote those observations down in texts that have survived thousands of years. Modern clinical researchers, with randomized controlled trials, with molecular biology, with Nobel Prize-winning cell biology, went looking for the mechanisms behind those ancient observations, and they keep finding them. This does not mean ancient medicine was always right. It was not. It does not mean modern pharmaceutical medicine is unnecessary. It is not. It means that the accumulated clinical observation of pre-scientific cultures, particularly around food as medicine, captured real biological effects. Effects that modern science is now explaining at the molecular level. The most important thing I want you to take from this video is this: the foods at the top of this ranking, olive leaf, black seed, olive oil, fasting, fermented grain, are not exotic. They are not expensive. They are not locked behind a prescription. They are available right now at your grocery store for a fraction of the cost of the pharmaceutical interventions that target the same biological pathways. The ancient table was not mystical. It was practical. It was the result of thousands of years of careful observation by physicians who did not have laboratories, but who had something modern clinical researchers sometimes undervalue: generational empirical data at population scale. 15 foods. Ranked by clinical evidence. Validated by modern science. Prescribed by the ancient world. The research is real. The foods are accessible. What you do with both is up to you. If you learned something today, if one item on this list surprised you, if one clinical result shifted how you think about what is on your plate, hit the like button. Here is what that actually does. It signals to YouTube's algorithm that this type of research-backed, evidence-based content deserves to reach more people. The alternative: supplement ads and wellness influencers selling 80 bottles of pomegranate extract is what the algorithm serves by default. A like from you changes that calculus, even slightly. Subscribe to Covenant Table if you want this every week. No sponsors, no products, no affiliate links, just the research. Now I want to hear from you. And I mean this genuinely, because your answer shapes what I research and cover next. Drop a comment with this one thing. What is the chronic health condition that you have been managing for years, that conventional medicine has helped but not fully resolved? Not a diagnosis, just the symptom or the experience. Fatigue, inflammation, blood pressure, sleep, gut, cognitive decline. I read every comment. And your answers directly determine what I cover next. Because the research I do is more useful when it is pointed at real problems that real people are actually living with. Next week on Covenant Table, I am going to cover the ancient gut healing protocol, the fermented foods, bitter herbs, and structured meal timing that Scripture and the ancient world prescribed for digestive health, and what the 2021 Stanford microbiome trial says about exactly why it worked.